welcome back to the second tutorial of chapter 2 sets. So before moving on to the exercise, let's see some sets that we are going to use. An empty set. So an empty set is a set that contains nothing. As you can see, there is nothing inside, so it is an empty set. It is denoted by the symbol null set. This symbol with 0 and a cross line is known as null set. Example of an empty set: x is a natural number smaller than 1. Is there any natural number that is smaller than 1? No, there isn't any. So it is an empty set. Another example: x is an odd number divisible by 2. Is there a number that is odd, suppose as 1, 3, 5? Are those numbers are divisible by 2? No, they are not. So it is also an empty set. An empty set and a set that contains 0 are two different sets. It is a set with the value and element 0, where a null set is completely empty. Having a 0 in a set doesn't mean it is an empty set. Okay? Now, the next is universal set. So, it consists of elements present in the rectangle. It is generally denoted by mu or u. This symbol is known as mu. It is usually represented by rectangle. We will see here. This whole rectangle is known as universal set, denoted by the symbol mu. It consists of canines and incisors. All those teeth considered as a universal mouth. This is considered as a mouth. These are the insides of the mouth. Those are the types of teeth. Subset. By the name you can guess it is a part or a subpart of a set, right? If an element of a set A are represented in the set B, then set A is a subset of set B. For example, we will see B whole as a big universal set and A, a small set inside the B. B has the elements 3, 1, 2 because this A is also inside this B. So, the elements of A are also considered the elements of B, whereas the elements of A are only 1 and 2, which is only this circle part. So, A is a subset of B. A belongs to B, right? A subset is denoted by this symbol C and the line which is below it. Let's see here with the written example. Let's take B as 1, 2, 3, as we have taken 1, 2 and 3. Now, how many subsets we can make? We can make empty set, right? We can make only single set with 1, with 2, with 3 singles. We can make 1 and 2, 1 and 2, 2 and 3, 2 and 3, 3 and 1, 3 and 1. We can also make 1, 2 and 3. All these are the subsets of B. Consider any one of these as A, then the result will be A is a subset of B. Let's take 1 and 2 as A, then A is a subset of B. Now, let's look at as Venn diagrams. So, what are Venn diagrams? These circles are known as Venn diagram. There are different types of Venn diagram. Union of set means all together is known as union. Considering all the Venn diagrams, elements of all the diagrams, all the circles are known as union. A union B is equals to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Like universal is known as union. Whereas intersection of set means the only part that are crossing each other, intersecting each other. 2 and 4. A intersecting B is 2 and 4. Now, disjoint set that are not joined. These are separated, right? They are not joined together. So these two sets are known as disjoint. If we do an intersection between disjoint set, the answer will always be a null set. It is the point to remember which we are going to use in the further questions. Any intersection of a disjoint sets is always a null set. Remember this point. Now, the next one is difference of set. Difference means subtraction, right? If we subtract A minus B, the answer will always be the A. Consider this as the only answer. We are not even going to take the intersection part. So, A minus B is 1 and 3. we also don't take the elements that are present in the A which are intersecting in the another element. Whereas here B minus A if we are taking, so we are only going to take these elements of B, only this part. We are not going to take any intersection one or the A1, that is 6 and 8. Moving on to exercise 2.2. So the first question is, if A is equals to 1, 2, 3, 4 and B is equals to 1, 2, 3, 5 and 6, then find the value of A intersection B and B intersection A. So let's take the sets that are given. Given sets are A and B. Now we are going to take A intersection B. So what's A? 1, 2, 3, 4, 1, 2, 3, 4, intersection, 1, 2, 3, 5, 6, 1, 2, 3, there is no 4 here, it's a typo mistake, let's erase this, 1, 2, 3, 5 and 6. So what's the common? 1 here, 1 here, 1 we got, 2 here, 2 here, we got 2, 3 here, 3 here, we got 2. It's not in the question, so let's just skip it. Now B intersecting A. So what we got? 1, we got 1, 1. We got 2, we got 2 common. We got 2. We got 3 and 3 common. Then we take 3. So let's consider this as equation 1 and this as equation 2. So what can we observe? A intersection B and B intersection A are same, right? From 1 and 2, we see that they both are same. Second question. If A is equal to 0 to 4, then find the value of A intersecting null set and A intersecting A. We need to also specify what do we see in the result, right? So the given set is A, which is equal to 0, 2 and 4 and a null set. First is A and null set. Null set is nothing but an empty set. So if we are intersecting the values of 0, 2 and 4 and null set, so what do we get? Null set, because there is nothing common in this, we get an empty set. Let's consider this as equation 1. When we are intersecting A and A, obviously we got 0 common, 0 common, 2 common, 2 common, 4 common, 4 common. We get the value as A as it is, right? Let's consider this equation as 2. From 1 and 2, we notice that A intersecting null set is a null set and A intersecting A is an A. Third question. If A is equals to 2, 4, 6, 8, 10 and B is equals to 3, 6, 9, 12, 15, we need to find the value of A minus B and B minus A. So in the Venn diagram we have seen such type of questions, right? So given values of A and B. So what's A here? 2, 4, 6, 8, 10. And what's B here? 3, 6, 9, 12, 15. So the answer is 2, 4, 6, 8, 10. There is no common. Common elements will also get removed, but there is no common here. I'll just show you with the Venn diagram. Let's consider this Venn diagram and this Venn diagram. Okay. So it's A and it's B. So value is 2, 4, 6, 8, 10, 3, 6, 9, 12, 15. Nothing common here. So the whole A is the answer. Similarly with the B, we have 3, 6, 9, 12, 15, 2, 4, 6, 8, 10. Answer is 3, 6, 9, 12, 15. If we have any common values which are intersecting, then we need to remove those values. But as for now, we don't have. So from 1 and 2, we conclude that A minus B and B minus A are not equal. Fourth question. If A and B are two sets such that A is a subset of B, then what is A union B? So given that A is a subset of B, it's already given in the question. Let us consider two sets A and B. A as 1, 2, 3 and B as 1, 2, 3, 4. I told you how subsets work, right? Let's consider this as B and this as A. Okay? Now, this is B, this is A. So, what's the value of A? 1, 2, 3. We got 1, 2, 3 in the B, 4 and 5. So, the B is whole of this 1, 2, 3, 4, 5. But the A is only 1, 2 and 3. So, A is a subset of B, right? And A union B is all together. Union I said. Mu is the union which is all together. mu as union all together. So 1, 2, 3, 4 and 5 all together. So we conclude that A union B is equals to B. Fifth one, when we have let A is all natural numbers, B all even natural numbers, C odd natural numbers, and D are prime numbers. So we need to find A intersecting B, B intersecting C, A intersecting D, B intersecting C, B intersecting D, and C intersecting D. Okay, given sets are A all natural numbers 1, 2, 3, 4, 5, so on. B even natural numbers 2, 4, 6, 8, 10. C odd natural numbers 1, 3, 5, 7, and 8, and D are all prime numbers. So A intersecting B, we need to write first A 1, 2, 3, 4, 5, so on, intersecting value of B. So what's common we got here? Intersecting means common part, right? I'll just draw and show you a sample. Let's consider this A and B. So we will write the intersecting part. We got 2 here and 2 here, so 2 in the middle. We got 4 here and 4 here, so 4 in the middle. 6, 6, 6 in the middle. 8, 8, 8 in the middle. 10, 10, 10 in the middle, right? Whereas the rest of the values are 1, 3, 5, 7, 8, 9, and so on. When this is A and B. So what's the intersecting part? Which means which are present in both A and B. 2, 4, 6, 8, 10. Similarly, we got A intersecting C. A 1, 2, 3, 4, so on till 10. 1, 3, 5, 7 and odds. So intersectings are, the odds are present in here as well as here. 1 here, 1 here, 1 here. 3 here, 3 here, so 3 here. 5 here, 5 here, so 5 here. 7 here, 7 here, 9 here, 9 here, so on. Now, A intersecting D. A we got, and D is the primes. So, the primes are the only one that are present in the natural numbers. 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. Now, B intersecting C. What's B here? Even. What's C here? Odd. Is there anything common? No one is intersecting. We got evens here and odds here. So, we found a null set. We got a null set here as nothing is intersecting. Now B intersecting D, we got evens in the B, and D we got the primes. Only 2 is intersecting, right? Because only 2 is the prime here. 4 is not a prime, but we got 3 as a prime. 4 has factors, it is not a prime. Only 2 is the answer. Now C intersecting D. C is the odds, right? And D are the primes. So in those things, what are the commons? We got 3, 3, 5, 5, 7 and 7. Odds and primes intersecting is 3, 5 and 7. Sixth question. If A is equals to 3, 6, 9, 12, 15, 18, 21. B is equals to 4, 8, 12, 16 and 20. Where C is equals to 4, 2, 4, 6, 8, 10, 12, 14, 16. And D is equals to 5, 10, 15, 20. Find A minus B. We'll add the values of A and the B. Now answer is only the one that are present in B, not even the intersection part. We got 12 here, right? That is the intersection part. Rest the values of A are not in the B. So 3, 6, 9, 15, 18, 21 is the answer. Now A minus C, we got the A and C. So let's see what's common here. 6 is common here. We'll just remove this 6. Is there anything else common? 12 is common here. Let's remove the 12. Anything else? No. We can't even take the intersection part, right? When we are doing subtractions. Only the A part. 3, 9, 15, 18, 21. The rest intersection is removed. I'll just show you within one example of a Venn diagram. What's common here? 6 and 12, right? The rest are 3, 9, 15, 18, 21. Here 2, 4, 8, 10, 14, 16. So what is the value of A? Only this. Remember, right? We need to take only A, even not the intersection part. So that is what we have to take. 3, 9, 15, 18, 21. Similarly, A minus D, A and D, we got 3, we got 6, we got 9, 12, but we have 15 common here. Let's remove this 15, we got 18 and 21. We cannot take the intersecting part, right? B minus A, we got the value of B and A. So what's B? 4, 8, we got again 12 common. Let's remove this 12, 16, 20, which are not present here. Now C minus A, we wrote C and A. Similarly, what does we have common here? Again 12 common, right? We have 12 in the C and 12 in the A. So we got 4, 2, 6, 8, 10, 14 and 16, which are not present here. Now, D minus A, 5, 10, 15, 20, only 15, right? Let's remove this 15. The answer is 5, 10, 20. For B minus C, 4, 8, 12, 16, 20. We got 2, 4, 6, 8, 10, 12, 14 and 16 as C. So we have 4, 4, we have 8, 8, 12, 12, 16, 16. We only don't have 20. So 20 is the only B we got as B minus C. B minus D, 4, 8, 12, 16, 20 minus 5, 10, 15, 20. We got 4, 4, 8, 8, 12, 12, 16, 16. As we have 20 common, we are not taking that one. Similarly with the C minus B, let's remove the common stuff here, which is 12, 12, 8, 8, 4, 4. The remaining is 2, 6, 10, 14, right? Now, D minus B, we have only 20 common. Let's remove this 20 and we got 5, 10, 15. Now, the last question of the exercise is 7th one. State whether each of the following statement is true or false. We need to say whether these disjoints are disjoints or not. 2, 3, 4, 5 and 3, 6. So, what was the rule? I explained you earlier. The rule is if two sets are disjoint, then their intersection is always null set. We need to prove this statement. So, what are the disjoint sets we got here? Disjoint sets are like this, right? I told you how does they look. Two sets which are not intersecting. 2, 3, 4 and 5. Other is 3 and 6. These are disjoints. These are not intersecting with each other. So, we got 3 common as an intersection because we are taking the 3 common intersection. But the rule is if two sets are disjoint, the intersection is null. So, we are writing it as null. Is it true? No, statement is false because we have 3. So, it cannot be a null set. Next, given set are A, E, I, O, U, A, B, C, D. Again, we got A as common, right? Which is not equals to null set. Intersection means common part. We got A, it cannot be empty, so this statement is also false. Third one, we got 2, 6, 10, 14, 3, 7, 11, 15. Is there anything common? No. We got a null set. So, yes, this is equals to null set. It is a disjoint set equals to null set. This statement is true. Now, given sets are 2, 6, 10 and 3, 7, 11. So, the intersection value is nothing. Again, this value is nothing. It is equals to null set and the statement is also true. So, it is the end of the exercise today. Thank you.